Boards. That was what drove me to Python. Okay. All right.
It was the pinnacle.
All right. Let's take a look at more Matplotlib. This is still we're still doing base Matplotlib. This is like kind of your base graphics stuff, and then on Friday we'll look at like Seaborn, which does like stat stuff for us. So if you're using base Matplotlib, basically you've got to do all of your calculations and statistics and stuff, all of that in NumPy, and then once you have your NumPy arrays or whatever, then or you do it in pandas, then you throw them into Matplotlib, pyplot, do your plots. So here we'll just take a look at a few more plots here and a few options, and all right, yeah, okay. So here we go. So we'll do our regular old imports, and so we'll import NumPy, pandas, Matplotlib, pyplot as PLT, and then here I'm just doing some lines. I've got x versus x, the function is x plus 1 and x plus 2, you get these diagonal lines. And you can specify the color, and you can just say B for blue, G, and R for blue, green, red. And these are kind of your single letter abbreviations. So blue, green, red, cyan, magenta, yellow, K for black, W for white. Okay? And then there's a full list of colors that have names, which is, I think, pretty similar to ours named colors, but not exactly the same. So, but you know.
Wait, but they lose. Why are some of them repeated?
Huh?
Why are some of them repeated?
Why are some repeated? So you can spell gray with an A or an E, and that it won't get mad. Okay. And then you have chartreuse and lawn green.
Chartreuse is apparently lawn green.
Chartreuse and lawn green are very similar. I'm not sure what the difference is between pale green and light green, but
I feel like
whatever.
those two columns are
I think these are all like,
same.
Honestly, they look the same to me. I don't know. Is there a difference?
Medium spring green. That's fun.
Forest green versus green.
I like how some of these get weirdly specific, and some of them are just words strung together.
Okay. All right. Anyway.
Spring green.
Fuchsia and
that one's
whatever.
Rebecca
Okay.
purple. Why is it?
All right. This is. We don't need to spend 10 minutes debating color names. It's like going to the paint aisle. All right, and then you've got solid and dashed lines and dashed dot and dotted lines.
Oh, cool.
And you use kind of the symbols that look like them, except for dotted you use the colon, because then you've got two dots there, right? Okay, and then the lines look like this. And if you don't specify colors and you're plotting multiple lines, pyplot defaults to using different colors for you anyway. So, okay, and then if you want to make a scatter plot, everyone's typing away furiously. Here, let's we'll blow things up. Okay, so you can set the, you can just, here I just pulled some random numbers between 0 and 1, random numbers here. We got scatter XY, and this will do it. If I want to do axis equal, then we goes from 0 to 1 in both things. You can I think you can do figure size equals we'll go 4, 4. Oh, see, where is my? I've got to cheat.
Triangles.
I got to cheat and see. Oh, it's fig size, not figure size. See?
Fig size. See?
And then when you code in,
-1.
yeah, I know, right? I would lose a point, you know. And then when you like spend the morning coding in R, and then you switch to Python, it's like
It's so bad.
you gotta like stop and breathe, and I mean you gotta breathe throughout the day, but my life is so hard. It's not. It's not. Okay. Anyway, so this is what we have. All right. You can change a bunch of stuff. Okay. So here, I'm going to take some vector z and use it to modify the size. And so you know, the size things you got to like. If you just go from 0 to 10, the sizes are quite small. So this is like a size 1000 is like this circle right here is like size 1000. So you got to like multiply it by a huge factor for it to go. Okay, and then and here I'm picking numbers between 0 and 5 for the colors, and I set an array between, you know, red, blue, green, magenta, yellow, and I'm subsetting the colors here. Let me
Wait, what does W do?
yeah, let's throw this in here just so you can kind of see what I've done.
Wait, what does
So
the
I'll
W
print
line
Z,
do?
print Z, print W. So these are just vectors of numbers, okay?
Oh,
And then-
assigning colors.
And then when I basically subset the colors using these numbers, because I've got red, blue, green, magenta, yellow, and I subset the colors to give me this vector of colors. And so, you know, you could do this, and then you create the scatter plot, asking. Here, I'll scroll back for you guys. And I have to. I'm sorry, I'm like behind on uploading. It's easy. I just have to go to GitHub or Git and just say push, but I have to do that. Okay. Okay, and then so for the scatter, we do the same. We go x, y. S for size is going to be our vector z, which goes, you know, 0 to 1000, and then C for color will be our NumPy array C, and then alpha equal to 0.3 modifies the transparency. If I didn't have if I set alpha equal to 1, then they're just solid colors. Or, you know, if I set it to 0.3, then it makes them a little transparent, you know, and you can have like lighter colors and stuff like that. Okay, so that's fun. You can also change the markers. Okay,
Cool.
and you can make like triangles or squares or whatever. Unfortunately, you cannot. You can't map the marker. As far as I know, you can't map the marker to a vector of marker values. Like in ggplot, you can like map this plotting symbol, plotting character to a column or something. Here, it's kind of like you have to say, I want triangles for this set. You could like, I could add another set of points. Here, I will just switch them y and x, okay, and I will plot squares. Okay, and so you can map different shapes on the same plot, but you can't map the marker column to something else. All right, if that makes sense. Okay, and so you have all sorts of different markers. The point marker, the dot is that, and then the comma is a single pixel, and then what do we have? O for circle, V for triangle, caret for triangle up, V, so it's kind of like, this will be triangles that point down, and then you got triangles that point to the left, and triangles that point to the right, and triangles that point up. Okay, it's really exciting, you know.
That is really exciting.
Okay, well anyway.
Oh, look at all
And then
that.
if you want numbers instead, okay.
Stars,
Pentagons. Oh my goodness.
hexagons.
Let's.
I want to see hexagons.
I want to see stars.
Oh.
Oh, that just makes me happy. Okay. And then pentagons. Okay. So anyway.
Hexagons. Hexagons.
Yeah. All right. I'm gonna do this.
Aw.
Everybody gets a star. Okay.
See. Stars for effort.
Diamond.
Okay. All right.
Then
You can explore this. All right. Okay. I think we talked about subplots on Monday for the 5 of you who came.
Whoa. Shots
And-
fired.
So when you specify subplots, basically the command is plot subplot. Okay, plt.subplot, and here we're going to do subplot 231, and that will produce a plot in the, so 2 will be 2 rows. Here, let me just do this, okay? So this makes 2 rows of subplots, 3 columns of subplots, and work in plot I. Yes?
So here it looks like it's not 0 indexed.
Yeah, the subplots are not 0 indexed.
No.
Okay.
Why?
Yeah, the reason why is because when they designed Matplotlib, they were basing it off of MATLAB. And so that's kind of where the matplot comes from, MATLAB. So it's like MATLAB-based plotting. And MATLAB is non-zero based indexing. So MATLAB and R starts indexing at 1, Python and a lot of other things index at 0. And you know, my brain hurts at the end of the day. Okay. So here, you know, we're just creating subplots, and with this for loop, we haven't really covered for loops, but they're easy, okay? And oh yeah, in DataCamp you did for loops. Okay, so anyway, for loops. The great thing about Python is it's all based on indentation. So anyway, so we go from 1 through 6 basically on the range 1 through 7, and then we're just plotting, adding text, and the string that we're adding is 2, 3i. Okay. And so you can see kind of the labels for each subplot here.
Subplot 2 rows, 3 columns.
And work in plot I. So the first loop around, we're working in this one, and the second one, we go this way. And so it just, when you go 2 by 3, you're going to have 6 of them, and they just count across the rows.
What's the 0.5.5?
The 0.5.5 is where do we position the text, and it's
in the
positioned, it's centered at 0.5.5. If I did left align, then it will left align at 0.5.5. But
Okay, and that's HA.
yeah, for adding text to your plot. Okay, and you can use this command. So the first 2 will be where. So plt.text adds text, and first 2 will be the XY position, and then the string, the character string. So you can, instead of string 231 or 23i, you can plot in like hello, love. Okay, and then and so you get that, right? Okay. Oh yeah, do they have a heart character? No.
That would be so cute. Oh, you got our hopes up.
At the next one, I will push for having emojis plotted all over.
Yes.
All right, now.
So much excitement.
Somebody should make an emoji plotting package for R, or search for it.
You could get a PhD for that.
It makes a low bar for PhD. Okay. Yeah, emojis are a fascinating topic. There's a Unicode committee designated for emojis because they're now part of the. Anyway,
That
okay.
makes sense.
Yeah. Okay, and you want to make more complicated ones, you can do that. Okay, so here you do, instead of subplot, you do grid specifications, okay, grid spec. And here we're doing 2, 3, all right? So here we're still doing grid spec 2, 3. And then you can say, all right, I want the subplot on grid. So now it gets confusing again because grid spec uses zero-based indexing. So.
Stop this madness.
All right, so
You're killing us.
grid spec uses zero-based indexing. I'm not doing this on purpose. It's just
You're enjoying watching us suffer.
I don't enjoy this any more than you do because I get stuck and I'm like, why? Oh yes, 0. Okay, so grid 0, 0 means we'll put the plot right here, and then here for 0, 1 colon will be basically 1 and further on there, and then so on and so forth. So the top left is 0, and then it counts downward and rightward, okay? And this will be kind of like the row and the column, okay? And so with grid spec, if you have the patience for it, you can do a really more complex plots. Now I didn't have the patience, I just copied the code out of our textbook, okay? But I added some commentary on it, okay? So here we start by generating some multivariate normal data, okay, using random.multivariate normal, which that makes sense, okay? I think in R it's called MVT norm. Here it's just multivariate underscore normal. You give it the mean vector, the covariance matrix. You say I want 3,000 values, and then it returns back basically a tuple, not a tuple, kind of these two arrays, x and y, after you transpose them. So we capture those and we say keep those as x, y. And then what we're going to do is we set up a figure, okay? So our figure is going to be in the figure, it's a 6x6 figure, and then we specify a grid that's 4x4. All right, and then our main plot, okay, will be we're going to add a subplot to the figure, and it's going to be in grid from blank to -1 and 1 forward, okay? So if you think about, so if you imagine a 4x4 grid where 0, 0 is in the top, okay? Colon -1 says as far as vertically goes, we're going to start at the top and go down basically to the third one. It won't go to the fourth one because we want to leave one more. And then the 1 colon will say start at the second column and go all the way to the right. Okay, so basically you have a 3x3 box in the upper right of the grid for the 4x4 thing. Does that make sense? And then we're going to add a histogram over here and a histogram over here. So the Y histogram, it says add a subplot grid from the top to -1, so from the top down to the third, and then put it in the first column, 0. X tick labels say we don't want any labels on the X axis, and then share Y says use the same Y limits as the main plot, okay? And so here we, one thing we're doing that might feel a little strange is that we are capturing everything that says plot.figure and all of this. We're capturing that output into different variables so we can specify which plot that we're talking about. Okay, kind of like in R and ggplot, you capture the plots into some object, and then at the end you do print the object. Okay, so it's kind of like that. We're capturing basically the instructions for the plot into these objects, and we can then reference those objects. Same thing with the X histogram. We say, you know, subplot, do it in the last row, and then from the second column all the way to the right. Okay. We're going to add, so on the main plot, we're going to add basically our x, y coordinates, which are multivariate normal. Okay. And then we're going to add a histogram to the subplot that's labeled X histogram, and we're going to add a histogram to the subplot that's labeled Y histogram. Okay, so the histogram is X with 40 bins. These are just additional things. All of these things you can look up pyplot.histogram and stuff like that. Orientation vertical and invert y-axis flips them around. And then over here, orientation horizontal, invert x-axis flips it around. And all of that code just to produce this thing. Okay, but it looks nice, but it was a lot of work, right? So you can, you know, I hope at least like going through this code at least makes sense. You know, if somebody said do this from scratch, it would be a pain. You'd figure it out eventually, and it'd probably take you a while to do it, but you could do it. But at least I think when you read through this, it makes sense what's going on. So we set up a 4x4 grid. We dedicated 3x3 to this thing, 1x3 here, and 1x3 here. Okay, we didn't put anything down here. Okay, so as far as histograms go, you can just take, you know, a vector of data, throw it into histograms, and this is kind of the default thing. And you can add more bins. You can change the alpha. There's different histogram types, and here apparently for the color we chose steel blue, and an edge color we put none. But all of this stuff you can always go to just do pyplot histogram. Okay, so pyplot's like the submodule in matplotlib, and so when you do this, it lists off kind of all of these different stuff. So density will change it from counts into kind of the density values, and then yeah, cumulative will make it from a PDF looking histogram to a CDF looking histogram, and then you've got histogram bar stacked, step filled. Okay, so these are the whatever different options here. Okay. All right. Oh, I forgot I didn't run this yet on my machine. Okay, and then if you want to have so here we just said make a whole bunch more data, and again I just stole this from our textbook. So here we said make a bunch of different things, and then here instead of having to just copy and paste the same settings for all of them, you can have keyword args. Have you guys seen this yet? No, it's yeah, in Quargs. Okay, it's in one of the data camp things, I'm pretty sure. But basically, you can pass a dictionary of arguments. Okay, so you can pass a dictionary of arguments. So rather than having to say histogram equals step filled, alpha equals 2.3, density equals true, bins equals 40, and copying and pasting this, and then later on you're like, oh, you know what, I want to change alpha to 0.2, and instead of having to go into every single one and changing alpha to 0.2 for all of them, you can just change it once. So here we define a dictionary with these things, and then to pass the dictionary values, you have to do ** quargs, okay, keyword arguments and quargs, yeah. So you're basically passing a set of keywords along with their arguments, okay? And you do **, and this lets Python know, you know what, I'm passing basically a bunch of stuff, and then it will take all of them to account and create the histogram accordingly. Yeah, question.
Can you name that whatever you want, or is there something?
Yeah, it.
But is it like numpy as np is a kind of a...
Yeah. No, you can call it something else. And that will work fine. It's just Quargs is kind of the yeah, when you pass a thing like this, it's called Quargs, and that's kind of the general thing. It can be named whatever you want. So you might have multiple sets of Quargs, and you probably would want to, for convention, call it Quargs, but then Quargs underscore something if you have multiple sets of these things. Yeah. Okay. And then here are like two-dimensional histograms. Okay, so they're like density plots and things like that. But this is effectively a histogram where the shade of the color represents how dense it is. Okay, we'll stop here for today, and then we'll take a look at some stat stuff with Seaborn on Friday.